Pratik, light
Go
off करते
ahead,
नहीं वाले.
share. So
Your lights
mainly
बंद कर.
this fellow is OSCP, OSCE,
हाँ,
and he's
पूरा बंद
also
कर.
gotten into the Hall of Fame for Apple, Synology, Netgear, and OnePlus. So let's get started to understanding reverse engineering and what he has in store for us.
Perfect. Yep, you can go.
Hello everyone. Good afternoon everyone. Good afternoon. आवाज थोड़ी हो रहा है कि तो अच्छा लगेगा मुझे. That's good. Okay, so before starting, I would like to introduce basically myself. I'm Togir, and here I am for shell coding, basic assembly language and shell coding. And this is my first talk in this way. So let's start it. So, okay, this is like traditional for all slides, which I hate most about myself. So, this is, I'm a security consultant. Don't ask my daily job role and everything. I have a very versatile role in my organization. We have a startup actually in Pune. So, and about exploit developer, so I'm the one of the contributor in Metasploit framework. Maybe all you guys know
Yes.
Metasploit.
Yes.
कितनों को नहीं पता है Metasploit? चलेगा, हम इसे सीख लेंगे बाद में. Okay, so I'm exploit developer in Metasploit. I have written more than 10 exploits in Metasploit, I can say. And maybe you guys heard CIS benchmark. So I'm
Yes.
one of the author in CIS benchmark, which is newly released PSN CIS benchmark author. And bug hunter again, I do bug hunting very occasionally. Okay, आज कर लेते हैं, पैसे कम हो गए. Okay, तभी मैं करता हूँ. Okay, and हाँ, Python अच्छी लगती है.
Yeah. Yes. Yes.
सारे Python वाले? Simple, yeah, exactly, simple. So that's why I'm here. वैसे मैंने Python इसीलिए लिखा है ताकि सबको अच्छी लगती है, इसीलिए मुझे भी अच्छी लगती है. सब इंजीनियरिंग कर रहे हैं, इसीलिए मुझे भी इंजीनियरिंग करनी है. वही कॉन्सेप्ट्स के लिए मैंने यहाँ लिखा है. And yeah, I was a CTF player in 2017, 18 or 16 era. In on Hack the Box or different platforms. Nowadays there are so many platforms you can play on. Okay, so usually I use war games for GPU, Natas and everything. Okay, so target audience students. So I'll make sure this slides will not too much for you guys. I'll try to explain in very layman terms so that you can understand more. I will not give you a very big words, I would say, right?
Right.
And cyber security professional, again यहाँ पे कुछ हो गए. cyber security professional अंकित
Yeah.
right? अंकित है, ये भी है, बहुत सारे लोग हैं. And who is interested in reverse engineering actually. So okay, I guess सभी interested है, इसीलिए हम यहाँ पे हैं. टीवी होती है, so मैं ये नहीं पूछूंगा. And
Alright.
what will this session cover? Actually, मैं एक चीज़ और बताना चाहूँगा. This is very short notice session, so that's why I don't have too much to show you. But maybe in future I can show you much better slides. अभी आप लोगों को बहुत plain slides दिख रहे होंगे, no interaction, nothing. So that's why I am actually trying to interact with more and more, so that कोई सोए ना मेरे talk में. So here I'll give you a basic introduction about the assembly language and system calls, and I'll show you one or two demo maybe. Requirements, if anybody have their piece, their laptop, they can actually perform
I have you.
with me, or logical thinking and time and patience. बहुत बार it will not work as expected, so we have to we have to be patient. ठीक है. जय माता दी हो जाएगा. So this is the today agenda. Like I'm going to cover assembly language system call, and I'm going to show you some like assembly code, and we will write assembly code for executing a bash script or maybe hello world. Everything will be fine for me, and like I'm going to cover like how you can actually execute those assembly code into the like executable format, so you can actually execute your code, right? So before starting everything, I just wanted to show you something. Just give me your opinion, your idea, what. So this is familiar with you, like
Yes.
actually back वालों को बहुत तकलीफ हो रही होगी, I guess.
Can we zoom it?
हम just नहीं कर सकते.
That can work.
ये कमांड फेमिलियर है आप लोगों को?
Yes.
कितनों को? ओके, सारे स्टूडेंट में एपीके तो बनाई होगी इससे.
हाँ, yes.
सभी ने एपीके बनाई है इससे?
Yes.
अपने फ्रेंड को भेजिए.
We
और
should.
फिर ये सोच रहे हैं हमको शेल क्यों नहीं आ रही है?
Yes.
कितने हैं ऐसे? मैं तो था. मैंने तो पोकेमोन गो जब लाइव चल रहा था तो मैंने वेबसाइट तक बना दी थी और एपीके बना के लोगों को दे रहा था. पिकाचू मिलेगा. So पिकाचू तो नहीं मिला बट शेल मिली मुझे. So okay, this command looks familiar, right? And ये जो verb में लिखा हुआ है नीचे. So do you know what is this? This talk.
No.
How many of you know actual this code? कितनों को पता है?
बाइट कोड्स है.
हाँ?
बाइट कोड्स है ना.
Yes. हाँ, आप ही बता दीजिए.
कुछ नहीं थे, जस्ट बाइट कोड्स.
Okay, और कितनों को कुछ पता है इसके बारे में?
Looking at this, it just looks like a buffer.
Okay, so this is a hex code actually, bytecodes. Okay, so you can use this code and inject in your buffer or inject in your like
Right.
shell or whatever
Yeah,
you
right.
have. Like mostly if you have experience in the buffer exploitation,
Right.
like memory exploitation, so maybe you are aware with these codes. Okay, if you are not aware with this code, maybe you are aware with the assembly code. EAX, EBX, जो हमको माइक्रो प्रोसेसर 886 में तो खैर AX ही होगा सिर्फ. It's not a 32 bit, it's a 16 bit I guess, right? 16 bit है और 8 bit है.
What?
16 है ना, मैं थोड़ा कमजोर हूँ पढ़ाई में. So
16 bits. Xcode, right?
So, yeah, so here we are going to cover this thing, like this hex code. So first we will write a code in the assembly language, and after that we will execute maybe 1 or 2 commands to get this hexadecimal code. And we will try to inject in any buffer or any programming and any code to execute our actual code. Okay, so
Just do one thing. Tell anybody who has a PC. Ask them whether they can record the session.
okay, so introduction to assembly. So assembly is a low-level programming language, and it's also depend on the architecture to architecture. Like in 64 bits, you will find the RAX, RBX. In 32 bits, it's a EAX, EBX, and in 16 bit EX, right? So on. So how many of you guys know what is high-level programming language and low-level programming language?
Everybody. I guess everybody. Everybody knows what is high level and what is low level.
Anybody wants to answer?
Everybody knows that, right?
आप speaker देना पड़ेगा, उनको mic देना पड़ेगा सब.
Yep. You can speak.
Yeah, please. What is high-level programming language and low-level programming language?
Low level basically assembly language is where जो भी से हाई लेवल
Let-
जो भी लैंग्वेजेस जिससे हम कोड करते हैं वो high level.
Okay, maybe. Yeah, please.
So basically, low-level languages are those which are very easily understood by the machine, but not the human.
Yeah.
And high-level languages are which we can like if it takes the example as Python, we can read it like an English language, but it is very hard for machine to understand it. So we need interpreters and compilers for that.
Right. Great, actually. Great. So, in low-level programming language, it is very difficult to code something. Okay, in low-level programming language, you will not find a for loop or direct print statement or direct execute statement. Okay, but in high-level programming language like Python or C, so there are predefined function, built-in function we call built-in function. So you can use those built-in function to directly execute or directly perform operation with like OS level. In low-level programming language, we have to rely on the registers, okay, and we have to give our instructions or like let's say I want to run bash, it is bin bash. So I have to give the bin bash in the low level, in the stack and everything. I have to arrange my memory structure or register structure in a manner so it will execute my bash script. Okay, so in later on I will discuss this only. But in low level programming, it also give you a more control on the size of your program. Okay, you can precisely calculate after compiling your program, it will be how many bytes or like bits or whatever. But in high level programming, let's suppose like you write C. In C or C++, if you write code for executing any command, so you will not know like how many bytes or how many data it will take. Because when we write a C++ or any other library, let's say in Python, we import OS.
Right.
OS.system and subprocess, so many submodules are there. But let's say OS. But in this program, we need only OS.system, right? But if you import OS, so it will import everything, whatever in that code, it will import in your current program, right? So that's why like low-level programming language give you a more control over a size, and we write like very basic like and EAX 37 and EAX 37 or 22. So this called Munix. Pronunciation issue. So this called Munix. You can write low-level programming, but you have to first understand what is the register, like general purpose register. So what is the register, general purpose register, special register like EAX, stack pointers, base pointers, and like so there are so many registers. So here I will make sure this will not overflow your mind. So I'm only giving you a like general purpose register because we can serve our purpose using these registers. Okay, basically general purpose register you use for saving your data. Okay, you can temporarily hold your data in these register, but make sure this is the 32-bit in size. Okay, so it will only hold your 32-bit data. Okay, and one question actually. One question for you, like आप कैसे आइडेंटिफाई करते हैं कि कोई भी सिस्टम 32-बिट है या 64? लाइक अगर रजिस्टर लेवल पे बताना हो तो हाउ यू कैन सी दैट? ओके, जैसा उन्होंने बताया नंबर ऑफ बस और या
एक्चुअली आई गेस हमने फर्स्ट बताया था कि नंबर ऑफ बसेस हम नहीं चेक करते हैं क्योंकि जो इंटेल की 86 जो सीरीज है उसके बसेस एंड जो रजिस्टर का नेम है वो काउंट करता है। हाँ, सो आई सीरियल पोर्ट्स को चेक करते हैं कि कितना है उसके हिसाब से
Yeah, there are
quite sure.
easily you can say like if EIP is 64-bit, so it's a 64-bit processor, right? EIP because you can use general purpose register like in half, but EIP half में use नहीं होती, right?
The size of the base register.
Yeah, the size of the base register, EIP, ESP, or like
Instruction
EAX,
pointers.
yeah, instruction pointer. EIP is instruction pointer.
उसका length and like the buffer that
Right.
it has. AX होता है फिर you can identify.
Right. Great. So again, one more thing, like assembly language will vary architecture to architecture. Okay, and there are like GNU and Intel format. You can write your code in any of these format. This is not like you have to write Intel in Intel and GNU in GNU. Actually, G. GNU.
GNU Linux.
And this is a stack. Maybe you heard about stack. कितने aware हैं stack से? Okay, so बहुत सारे लोग आंसर दे सकते हैं.
Oh no.
कोई stack के बारे में कुछ बताना चाहेगा? कोई comment? I guess आप कुछ बोलना चाहेंगे?
It's the mic.
Anybody? Yeah, what? Please. Yeah.
Each time there is only one end.
Please. Share with everybody.
Basically, stat is like an store and
Storage of data.
each stat there is only one end. So,
Sometimes
each stat there is a
questions.
operation.
We have the same
Stat
question.
is
They have
a
to
first
be on the mic.
So last statement we insert which data not first.
Right. Yeah. You just mentioned pop and push.
There is only one end.
Yeah, there is only one end, but for a pop and push, on stack there is only two instructions. You can perform operation like pop and push. For pop, like getting any values from a stack, and for a push, it's like push naam hi push. Right?
Yeah.
So, why I'm talking this in like this basic introduction, because we are going to use stack for holding our bin bash value. Okay, because if you say bin bash, it's quite long. It's not 32-bit long, right? It's quite long. So we are going to use a stack for holding our bin bash path. So system calls. Anybody know system calls? Yes, college में बहुत studios हो गए और please.
Or like maybe we are interested in reverse engineering. So there are basically some calls that, as the name suggests, that the system understands. So if you look at some disassemblers or debuggers, what essentially these means are that there are certain flags that are dedicated to such calls. So let's just say there is one which is interrupt. So you interrupt after a specific line or like a specific command is executed. So there is also trap, which is executed after every command. So it's a very good practice, like when developers want to debug their a specific command to check its functionality, they can put a breakpoint there and uske baad they can interrupt it, or maybe just interrupt and continue.
Okay.
So that's how they get the entire contents of the stack. So stack, it is an instruction sequence. So as to say, that's why we've been using stack diagrams. Usme we have base pointer, instruction pointer, and memory registers and everything.
Great, actually. Yeah, काफी कुछ पता है. More thing, like as she mentioned, like breakpoints. So how many of you know breakpoints? So आपको पता है technically breakpoints कैसे होते हैं? Technically, if you go onto the like low-level programming, so how entire program execution got stopped? You know that? Anybody else? कोई किसी को? Sorry?
execute code and exponential program.
You can actually set a breakpoint in between program.
Yes, like red रंग का एक arrow हम देते हैं.
Yeah, exactly.
Arrow
तो वो आपके लिए देता है, right? आपको पता है वो break point कहाँ पे है. But on system level, because here we are talking about a very low level, right? Not a UI, not a very high end कि वो arrow है इसलिए वो डूब गया वहाँ पे, right?
jump करना होगा वहाँ पे I guess.
Okay, good. So in very low level, so there is one instruction CC. If you guys read about this CC instruction, so this is an actual breakpoint. So when you set a breakpoint on your program, so what your debugger do? He actually remove that instruction, or you can say he actually add CC instruction in between. So when your program run, okay, when your program execute and appear he hit CC command, so he got stuck, like system stop. So this is how breakpoint actually work on very low level programming language. Maybe you can read more about this on Intel manuals. So there are so many manuals you can read. If अभी तक interest नहीं आया तो ठीक है. So as I said, system calls request a service from OS. Like it could be a read, write, execute, or anything. Like हम Python में लिखते हैं open and file name, right? So in the background Python भी compile होती है, if you know, right?
Right.
Python भी compile होती है तो वहाँ पे वो instruction use होता है open का system call. And if you wanted to know more about, you can use strace command. Execute your program with strace. Strace command है Linux में. If you execute your command, like आप घर पे जाके bash को execute करना, but उससे पहले strace command लिखना. So strace is for tracing a system calls. So it will show you like अभी ये file open हुई, अभी ये file. Like maybe everybody here should know like bash execute होती है तो profiles भी load होती है. So you can literally see in your output कि वो profile भी load हो रही है. Open command, open system calls हुआ and profile path का and load हुआ सब कुछ. Maybe I can show you right now.
किसका
Okay, so
तेरा ही है?
I'm executing like bash with strace command. Okay. So right now this is I can understand it's very difficult to see from a back row, but I'll use a magnify glass so that you can actually see. So here so these all are system calls actually. If you see here, the file open. Let's see this. Thank you. Okay, so this is visible, right? Okay, so as I said, there are so many system calls, including read, write, execute, close, whatever, like so many calls. So this is also read call. So here you can see I have executed the bash Okay, so bash will initialize your basic profiles in etc bash.rc or rc bash. Actually not recall properly. So this is bash rc. He's tried to include in the bash script. So we try to read the bash rc file, and according to that file he will execute, right? So this is a system call. It's a very basic example, like if you want to see system call in action. So this is how you can actually use your command and you can see all the system calls. And one more thing, like this will also very useful in your malware analysis, because let's say if you execute any file and file will not give you any output, okay, so you can use strace command. You can use strace command to trace all the system calls. With system call, actually this binary it's doing, right? Maybe there are some hidden system calls. If you are not doing this, you will never find like there is a system command who actually read your bash RC file, right? So maybe you are executing any file which is reading your personal data and maybe like other stuff, right? So this is very essential when you like jump into the like reverse engineering or malware analysis. So you will find this command very handy. So this is for like this tip. You can write down the command, or maybe you can explore at your home, right? I'm not putting all the system facilities command. Okay. So as I already said, like there are so many system commands, and this is like a basic. This is a basic example of assembly language. Maybe you know these kind of commands in your x86 programming, in your microprocessor, microcontroller. Maybe you come across this kind of and QA, right?
किसने बनाया ये?
किसने बनाया वो? But QA सबसे बड़ा pain. So this is a, as I said, this is a low-level programming language. So here it is very easy to understand your CPU. Okay, what you want to do. Okay, so here I am doing like this is called mnemonic.
Yeah.
Mnemonic. Okay, slip of tongue. Sorry. So this is a mnemonic, and this is a basic instruction, XOR instruction. Okay. I'm performing XOR on EAX and EAX. Both register are EAX. Okay. So why I'm doing this? So I'm before. Okay. So let's jump into the programming, and I will wind up my session quickly. Okay. So. First, let's say we want to execute bin bash or maybe sh, bin sh. You all know what is bin bash, right? कोई किसी को नहीं पता है bin bash क्या होती है? अब सब सो गए लगता। कितने लोग उठे हुए हैं? अभी कुछ लोग आके खोल के सो रहे।
It's okay, it's okay.
Okay, so bin bash, if you are a CTF player and if you are in cyber security, so you will know what is the importance of bash. If you are doing like bug bounty and somehow you execute bin bash in your target, it's bounty hai, right? So किसी ने शेल सिस्टम शेल नहीं है बाउंटी में अभी तक?
बाउंटी में नहीं, बट
रिवर्स शेल और बाइंड शेल, एनीबॉडी नो रिवर्स शेल और बाइंड शेल?
Reverse shell, yes.
रिवर्स शेल,
Yeah.
बाइंड शेल,
No.
Bind shell.
और कोई?
We should start.
हर क्लास में
I
आगे
think-
वाले स्टूडियोस होते हैं क्या?
ये ऐसा नहीं है मैं तो और टीम का नहीं हूँ.
So please, can you explain what is reverse shell and bind shell?
रिवर्स शेल में क्या होता है कि अगर हम लोग रिवर्स शेल में मुझे ज़्यादा यूज़ किया जाता है ये कैसा है कि है ना हम लोग क्लाइंट टारगेट से कनेक्शन हमारे यहाँ पे लेते हैं
Bind shell
तो वो रिवर्स शेल है.
और session वहाँ पे.
Bind shell
नहीं,
है
नहीं, नहीं, आप यूज करो बहुत अच्छा
पर
लगता
session
तो
उनके
बाइंड शेल में क्या होता है कि है ना अगर आप टारगेट को एक टारगेट पे अपने कोड पे कनेक्शन हम खुद अपना कनेक्शन वहाँ पे मतलब एस्टैब्लिश कर रहे हैं तो बाइंड शेल. रिवर्स शेल का मतलब क्या होता है कि सामने से कनेक्शन मेरे पास आता है. तो मोस्टली मतलब वो ज़्यादा प्रिफरेबल रहता है बिकॉज क्या होता है कि अगर आपको फायरवॉल जो रहती है उसको मतलब अगर बाईपास करना है तो नॉर्मली हम लोग कोड लेके के सामने वाले से कनेक्शन देते हैं तो वो फायरवॉल ज़्यादा सस्पेक्ट नहीं करता. सोचता है कि भाई ये वेब ब्राउज़र ओपन कर रहे हैं ऐसा.
आपने ही है जाने देते हैं इसको.
यस.
राइट, ओके, आप
I can just tell about reverse shell only.
no problem. Please educate us.
Oh,
Together-
reverse shell most of the time.
Can you just give mic?
Continuing to the initial example that we took about the Android one.
Okay. APK one.
APK one, yes. So basically, establishing a reverse shell basically is establishing the connection with the target, like remotely controlling any device where we have which we have exploited. Most of the time using Metasploit and Android hack, of course. Yeah, like establishing connection with the target and exploiting exploiting it basically.
Right. Good. So yeah, as he said, or like this guy said. So reverse shell is basically when you get a connection from your target machine, and bind shell basically it's bind a port. It's like binding a port on the target, and you can easily connect. So depending on your situation, you can use either reverse shell or bind shell. But like again, the main goal is to executing a bash, right? Executing a bash script. In fact, in our CTF experience also, we try to execute a bash using a reverse shell, maybe an NC command or Python command or PHP. Right. जैसा भी environment हो, we try to execute a bash, right? So here, right now I'm going to show you how you can execute a bash. Okay, which is a very easy like bash likha or execute. Yeah, that's what I'm going to show you, but in the assembly language. Okay, so this is actually instruction sets. This is actually a program for executing a bash. So what I'll try to give you like each line introduction, introduction I would say. Like I try to give you a brief about each line.
It's okay. It's okay. It happens. Sometimes it happens. Yeah. मेरा बंद है.
Okay, so I'll try to give you like each line of brief so you can understand, and maybe you can write your own shell, not scripting, shell coding.
Okay.
Okay, because if you want to do this in a shell scripting, just write a bash और कुछ नहीं करना, right? So, but before moving on the actual code, let's understand system calls. So what is system call actually and how it look like? So I have one website which you can refer for a system calls.
help कर ले.
So here I'm going to show you 32-bit. Okay, we are not going to focus on 64-bit, and so I'm going to show you like in 32-bit and 64-bit the system call number will be different. Okay, so make sure if you are writing for a 64-bit, you have to use a different number for a same system call. So here, this is a 32-bit call, and For reading anything, you have to use 1. This is a code: read, write, open, close.
These are all system calls, right?
Yeah, this is all. But we are going to cover this exact. So using this system call, you can execute any script or any program in your OS. So as I said, like system call, it's like you can request any service from your OS. So this is how we are going to request a service from OS to execute my bash. Okay, because as I said, like in assembly you cannot write exec or you cannot write open or anything like that. So what you have to do, you have to use the system calls number. Okay, so these number will be in a hexadecimal. Okay, so if you go here, so this is the system call number. You have to use this in your program, in your assembly program, for executing your given path, whatever you give in the path. So I can also show you. So here you can say EX reference, system calls, exact, and reference, EAX, EBX. Here you can see like this is arg0, which means argument. Right? Python में भी arg ही लिखते हैं, arg0, arg1, whatever. So this is the first argument, and here you see like this is a first general purpose register, which is a EAX. Okay, this is a new format. This is not a Intel friendly. So this is the first instruction in general purpose, which holds your system call number. Okay, and this is your first argument, and then second argument, ECX, EDX, and so on. Okay, so let's move to this. So this is 0V. Okay, so this will come in a EX register. Okay, make sure your EAX is set to 0B or B. And after that, your constant file name, your constant character file name. If the like आपको Python में C में करनी होती, you can easily write exact. फिर bracket में you can write a path name, file name, bytes, whatever, right? Depending on the function, of course. So this is a constant. कि कितने कैरेक्टर्स है, एंड बस हमें ये तीन आर्ग्यूमेंट सेट करने हैं. दिस इज अ फाइल नेम, राइट? सो व्हाटएवर यू गिव इन द फाइल नेम, इट विल एग्जीक्यूट एंड एटलीस्ट ट्राई टू एग्जीक्यूट, अगर वो एग्जीक्यूटेबल होगा तो, राइट? सो this will come in EBX, ECX, EDX. Okay, so we need only this character. Now let's jump to the slides.
Just looking.
This is so confusing, right? So XOR EX. So here I'm cleaning my EX register because you can say in like if you are executing anything, you really don't know which like value holds EX register, EBX register and different register, right? You have no idea कि आपके registers कौन सी value set करें, right? So doing XOR or any
No.
Okay, doing like XOR on any instruction. So let's say I am doing a XOR EX, so it will become a 0. अगर आपने लॉजिक गेट्स पढ़े होंगे एवरीथिंग, हाँ अगेन ये वहीं से आया है. XOR ये वही वाला XOR है अगर मैं बात कर रहा हूँ तो. सो आप अगर सेम चीज़ पे XOR करो तो उसका रिजल्ट 0 ही आता है. So this will make sure निकाल के आपने null byte, sorry null poisoning मैंने कहा null byte injection. So आपने 0 ऐड किया, so program thinks okay इसके आगे कुछ नहीं होगा, right? कितने लोगों को null bytes पता है यहाँ पे? किसी को और आप बताना चाहेंगे? Of जो भी आता है आप let's share knowledge. Whatever you have, just share with others.
How much time do we have left for this session? How much time do we have left for this
It's
session?
fine.
It's already
fine.
crossed, I guess.
I'm also not sure.
It's okay. I've started,
Okay,
right?
ठीक है, ठीक है. Exam नहीं है, don't worry.
Oh.
वाइवा तो अर्गिस नहीं है.
ब्रेक में टाइम चला गया सारा.
नहीं, previous session पहला सेशन बहुत बड़ा था, पहला वाला
ठीक
session.
है, ठीक है, ठीक
उसने आधा घंटा ज़्यादा.
है. और किसी को null byte? Studious है. Sorry. I'm just talking about null byte. That's it. Actually, so मैं बताता हूँ. जब आप प्रोग्रामिंग लिखते हैं लाइक सी, लेट्स से सी, सो आप जब सी को कंपाइल करते हैं और आपने 11 कैरेक्टर्स लिए, ओके, आपके स्ट्रिंग में, और आप उसे जस्ट प्रिंट कर रहे हैं. सो इफ यू गो डाउन एंड सी इन योर स्टैक, सो वो 11 का 12 होता है, और 12 इट्स योर नल बाइट, वो 0 होता है. सो 0 वो इसलिए होता है ताकि प्रोग्राम को ये समझ में आए कि मेरी स्ट्रिंग यहाँ ख़त्म हो जाती है. सो दिस अगेन लाइक comes into the PHP application or any application because सारी चीज़ें वैसे ही डिफाइन होती है. इनफैक्ट PHP का इंजन भी C और C++ में भी उसी पे Zend और there are so many engines. So आप जब PHP में फाइल इंक्लूजन करते हैं और या कोई डिफरेंट वर्नेबिलिटी एंड यू डोंट वांट कि आगे का कुछ हमारे पेलोड में जाए, सो यू गाइस यूज अ नल बाइट इंजेक्शन देयर, राइट, 0 और वो हम लाइक URL एनकोडिंग में लिखते हैं बिकॉज इट विल ऑटोमेटिकली कन्वर्ट, राइट, क्योंकि एनकोडिंग इज अ वे टू ट्रांसफर योर डेटा, राइट. सो आपको URL एनकोडिंग में लिखते हैं एंड व्हेन योर प्रोग्राम एग्जीक्यूट योर फाइल, सो ही थिंक ओके ये नल बाइट रीच हो गया है, दैट मीन्स कि हमारा जो स्ट्रिंग था इट्स कंप्लीटेड. नाउ लीव एवरीथिंग जो भी स्टैक में उसको स्टैक में रहने देते हैं. So this is how you use null byte. In fact, if you anybody here who actually reading about buffer overflow, so आपने null byte भी सुना होगा, right? And it's very dangerous in buffer overflow if your payload contain null bytes 0. So आपकी exploit work नहीं होती है, right? आपने सुना है, ये देखा है, राइट. सो सेम कॉन्सेप्ट यहाँ पे भी सेम ही कॉन्सेप्ट है, सब जगह वैसे सेम ही होता है. सो दैट्स व्हाई आई ऑलवेज फोकस कि लर्न द बेसिक्स, लर्न द कॉन्सेप्ट, नॉट द टूल, बिकॉज इफ यू नो द कॉन्सेप्ट यू कैन ईजिली यूज एनी टूल एंड यू कैन ईजिली क्रिएट योर ओन वे टू एक्सप्लॉइट एनीथिंग, राइट. So now this confirm मेरा EAX register 0 हो गया है. CDX is a way to EDX को सेट करने के लिए कि वो 0 है, क्योंकि यहाँ पे हम क्या यूज़ करने वाले थे, EAX, EBX, ECX, EDX. So EDX में हमको 0 ही चाहिए था, तो CDX is a way to say कि जो मेरा EAX है वो 0 EDX हो जाए. And this push, as we discussed earlier in this session, कि stack दो operations perform करता है, एक push and pop, right?
Right.
तो मैं push कर रहा हूँ कुछ data. So कोई बता सकता है ये data exactly है क्या?
Hex code? हेक्स को
हेक्स नहीं है
नहीं नहीं
हेक्स है, ऑफ कोर्स हेक्स है, बट एग्जैक्ट में क्या है या प्लीज? ओके,
सिस्टम एरर्स
नहीं और कोई
रजिस्टर एड्रेस,
सिस्टम
रजिस्टर एड्रेस, मेमोरी एड्रेस,
मेमोरी।
मेमोरी एड्रेस
एक्चुअली ये मेरा डेटा है, आई शो यू।
ऐसा डरा मत यार
तो ये डेटा आपको सिमिलर है कुछ? तो बेसिकली ये है हमारा //sh which convert into a hex in Little Indian format. It's Indian E. Okay, so this convert into a Little Indian format. So this becomes this string. So I can also show you maybe hex converter. So man pages किसी ने यूज किया है लिनक्स में?
सर
Manual pages,
Yeah.
man command.
यस
It's very handy actually. So there is a man page for ASCII.
फॉर अ मैन ना
Here you can see ASCII.
Man.
So as I said, this character 2F, right? These two. Let's find out here.
कितना सिमिलर है वो देखना चाहता था इट्स वेरी सिमिलर
स्लैश है ना
या दैट्स
फाइल ऐसे वाला चाहिए
एंड देन मस्ट बी एसएच slash is the file separator.
So here you can see,
पर वो ऐसे वाला चाहिए
right?
Okay.
These character 2F, मैंने बोला //sh है वो,
Right.
right? But this is actually 2F /, right? So here you can see, ये command है हमारा //sh, but यहाँ पे last में slash है,
2F, right?
right?
2F.
So why this? Anybody you know why this happened? This is a backward, not from a very traditional way कि simply // को convert किया 2F में और sh को convert किया उसके equivalent hexadecimal में. So this is backward because this is a Little Indian. So when you work on the memory level, okay, so you have to give a like backward, like अगर ये // है तो आपको पहले sh को भी उल्टा करना होता है hs and slashes को उल्टा करोगे तो // ही होने वाला है anyways, right? So that's why अगर आप यहाँ देखो 6873, so इसका भी अगर आप देखो
पीछे से लाइट बता रही है
यो h, right? So आपने sh को उल्टा किया, फिर आपने डबल स्लैशेस को उल्टा किया एंड अब वो पुश कर रहे हो कहाँ पे? स्टैक में. What is stack? Stack is a LIFO again, but where you can save your arguments, variable and everything. Because हम bin bash और bin sh करने वाले हैं, right? So and no, this is a more than 32 bit, right? So हमको सिंगल रजिस्टर यूज तो नहीं होगा, हमको 2 रजिस्टर यूज करने पड़ेंगे. So what we can do, we can easily push this straight into the stack. So when we want this to read, we can easily pop it, right, using a pop instruction, or maybe we just point our stack pointer to a register to read it for us, right? And same with this line.
2F, yes.
Same with this. This is a like /bin
Right.
and double slashes. I said backward, तो इसीलिए पहले मैंने sh, फिर मैंने bin, right? So ये उल्टे फॉर्म में जाएगा क्योंकि last in
First out.
से. So पहले वहाँ से वो वही निकालेगा, right? And then EBX. So हमने मैनुअल्स में देखे थे, हमें EBX रजिस्टर यूज करना है फाइल नेम के लिए, राइट? सो मैंने ESP यूज किया यहाँ EBX के लिए. So ESP, it's like currently pointing to the stack. और stack में भी हमारा क्या है? File name, right? So it's actually a file name जो हमने EBX में सेट किया.
Yes.
एंड अगेन मैंने फिर पुश किया EAX करंटली 0 है हमारा, हमने ऊपर 0 किया था क्योंकि हमें टर्मिनेट भी करना पड़ेगा, राइट? मैंने बताया था हमको टर्मिनेट भी करना पड़ेगा, अदरवाइज उसे पता नहीं चलेगा कितना एग्जीक्यूट करना है. एंड दिस इज EBX, ये भी हम 0 करेंगे. सो बेसिकली जब आप एग्जाम देखेंगे तो वहाँ पे फर्स्ट फाइल नेम, सेकेंड फिर हमारा स्टैंडर्ड आउटपुट इनपुट, यू नो राइट, 2 1 0. किसी ने फाइंड कमांड लिखा है, फाइंड स्लैश फिर वॉट एवर नेम 2 नल. सो 2 इज फॉर स्टैंडर्ड एरर्स, राइट? एंड अगर आप ये देखें लाइक 0 बी, सो हमने मैनुअल्स में देखा था एग्जैक्ट करने के लिए इट्स अ 0 बी और जस्ट बी, यू कैन यूज एनी. तो और वो हमें EX में सेट करना था. सो करंटली दिस इंस्ट्रक्शन इट्स अ 16-bit इंस्ट्रक्शन, सो आई कैन सेट इन हाफ ऑफ द EX व्हिच इज राइट हाई और लो. AX का सॉरी 8-bit इंस्ट्रक्शन है. So we can store in just AL, AH, or I can also store this in EAX में. But हमको उतनी मेमोरी चाहिए ही नहीं है, राइट? हमको शॉर्ट से शॉर्ट करना है. Because if you work on the like memory corruption and all, so the whole key is to make your payload shorter, so that you can easily inject in your like vulnerable system or anywhere else. So it will give you a like shell in shorter size, right? And this is 80 interrupt,
Right.
so in 80H it's actually interrupt when this when this instruction execute, so system stop everything and try to give you a service which you demand, which is found in AX register. So here AX register store my exec, and every other register store a argument of that function, right? So it will give you like whatever you demand, whatever request you demand. So again, so this is a basically a small what I can say programming, assembly programming, which help you to exact your bash script. And this is other actually which I'm not going to cover. This is different. This is hello world programming. Initially I thought like I can show you maybe 1 or 2, but right now just because of time issue I'm going to show you only one here. So this is the command for your like making your SH2 object file, and after that you can make it linkable, so you can actually execute that file. Okay, so let's do this in action. I have already prepared. Okay, so I can again give you a like demo. So this is my shell code. Here you can see the same code
Right.
which you saw earlier in the slides. This is the same code. And so So I'm going to execute this file. I'm first going to like make it object and then linkable, executable.
chmod? Chmod?
Not ch mode, huh? Not ch mode. This is a so this is the command. So just because of my system is 64-bit, so I have to mention like 32-bit. I want this in the 32-bit, not a 64-bit. But this is also a good practice if you are like if you want to compile any program in 32-bit. And one more question, like like before my talk, there is one talk malware, right?
Yes.
So do you know like most of the malwares कौन से architecture पे होते हैं 32 और 64 और maybe कोई different
32 पे होते हैं?
किसी को पता है 32 और कोई
32 only.
32
Yeah.
क्यों right so 64 जो bit होता है he support 32 bit right it's a backward compatibility so most of the like malwares 32 bit में इसलिए ही होते हैं ताकि most like more and more system they can cover because if any malware which only works on 64 bit so हम तो already prevented हमारा 32 bit है like 32 bit वाला बोलेगा मुझे कुछ नहीं करना है जो कुछ करना है वो मेरा इंटर सिस्टम कर रहा है एग्जीक्यूट ही नहीं करेगा right so most of the malware on 32 bit and that's why I'm also covering a 32 bit instruction so that if you learn malware analysis or maybe you use IDA Pro or any other tool so you can find out similar instruction in your binary right So this is my command. This is my file name, which holds my program. This is a text section. Okay, so about this text section, so maybe I can cover this in like later talks or maybe in advanced talk because there are so many sections in your memory management and in your stack. So that's why like there are BCC, there are text section, there are heap, stack, so many things are there, right? So this is a just text section of my program. And this is the command to make it object. Now we have an object file. Okay. Let's read it through. So now I have only 3 files: shell object and bash, which is my code, and build okay. So build to shell. This is just a script to extract only hexadecimal from any program. Okay, so I will show you in a little slides. And let's move to the LD command.
Just if you can. I'm not executing.
So this is my object and this will become my executable file.
You have the recording.
Okay? Any questions so far? So
Just close the bash.
now we have shell which is already a chmod. हमको करना नहीं पड़ा क्योंकि ये already executable ही है. Okay, so let's execute this with this command. The execute ऐसे ही होता है, right? So yeah, this give me a like sh because we mentioned sh, not bash. So as such, it's like less interactive than bash. So that's why like, initially I was in Bash. This is less interactive than Bash, so that's why this gave me just this. And again, there is no profile and nothing. We have a just simple call to execute my Bash SH, right? I'm not loading any profile. I'm not providing any arguments to my Bash
Yes, come.
in my exec call. I'm just giving a SH file name with 00. 00 means nothing, and I don't want to give any arguments further, right? So we got just shell, nothing else special like color and everything, right?
If you want to, we can, right?
Yeah, of course we can. We have to write a like more lengthy code than
Like a profile.
like to read a profile and pass into the arguments.
Like
and
the
so
bash
on.
SRC.
Yeah, you have to use a different system call. As I'll show you earlier in the slide, like we use a strace to trace 8 system calls, right? There was so many system calls. It's check your GUID, UID, and everything. And depending on your profile, bash, .bashRC, and everything, it give you a like Sundar sa bash, right? So just because of in the exploitation we just need bash or sh कि किसी तरह से we are able to perform a operation on OS level, right? So इसीलिए यहाँ पे हम सुंदरता नहीं लाते, हम सिर्फ execution पे ध्यान देते हैं, right? So, but if you want to write a more sophisticated, more advanced program, you can of course write. You have to use a multiple calls and everything. So here I am going to exit. So yeah, again exit होके मेरी bash पे आ गया, right? So this is what for my talk to execute a bash, but using a assembly language. So yeah, and you can also use like
When we used to, in our college,
pin to
we
shell.
want to
Okay,
end
I'm
any
going
talk,
to show
we used to
you.
do that, you know. It's not gonna execute, I don't think so, because he has created the programs himself. Oh, okay.
Okay. So this command gives you like your equivalent hex code, which you can like inject in your buffer to execute. So this is my like if you closely look into this, so you will find a 2F, which is a slash. You will find a 80, which is a like interrupt call, right? You can see 2F, 68, 50, all yes, 68, 2F again. So these are my file name actually, right, in the system. So this is very short program, right? You can see this is in like literally 30, maybe in bytes. So this is all for all for my demo right now. And again, you can use this program to enter your shell code here. It will give you
This is a C
like,
program.
it will give you your shell code layer and everything, and just execute your shell code, whatever the instruction in your shell code. This will execute simply using a C. This is a C program.
124.
You can use this, and you can extract those hexadecimal values, and you can put it here.
It's M2.
Okay, and it will just give you a like shell code length, which I suppose it's 30, maybe a 20 or 30 bytes, and again
I
execute your
covered
shell
it
code.
actually.
Okay, so
I did the
before
blog
that,
modified, but I have not edited it yet.
now you can actually relate this hexadecimal code with MSF Venom command, which I showed you earlier, right, in this slide. It will give you a like gibberish value.
Right.
For us, at least, it's gibberish, not for processor. It will give you in the hexadecimal code. और हम बोलते हैं शेल बन गई हमारी, चलो दोस्त टारगेट करेंगे हम पहले, और हम उसी दोस्त को टारगेट करते हैं जो कमजोर होते हैं, जिसके पास कोई डेटा नहीं। उसकी सोशल मीडिया में तुमको ऐसे देता है भाई मेरा हैक हो गया है, मेरा करके दे से, फिर भी मुझे समझ में नहीं आता हम उसी को क्यों टारगेट करते हैं जिसके पास कोई डेटा नहीं है। टारगेट करना है तो जरा जिसके पास डेटा है, लाइक समझ लो।
The more the data, the more the security.
हम्म
The more the data, the more the security. The more less the exploit works.
आई वुड से थोड़ा अपोजिट है, ऐसा होता है। लाइक आई हैव सीन सो मेनी लाइक प्लेसेस, द मोर डेटा यू आर द लेस सिक्योर यू आर। राइट नाउ लेट्स कंसिडर मी, मेरे फोन का हॉटस्पॉट चालू है और पासवर्ड 2 ट्राई में आप लगा सकते हो इजीली।
1 2 3 4 5 6.
बोल दिया सर, ओके। सो बिकॉज
नहीं, Rocky file थी इसलिए बोल रहा था। I said Rocky file थी, so I had a
easy रखते, keep it simple,
चुप है।
right? But still this is not a good practice, this is a bad practice। तो मैं अभी मेरा hotspot बंद करता हूँ क्योंकि
There is one more thing. Like some of the friends who have nothing, they keep complex passwords for no reason.
again है, ऐसे बहुत सारे एग्जाम्पल्स है। वो खुद आपके फोन में फेसबुक लॉगिन करके भूल जाते हैं, बट उनका पासवर्ड हमसे ज्यादा सिक्योर है।
You can't even
So,
consider
मुझे
it.
ऐसा भी लगता है like sometimes they don't have other password ना apart from Facebook, तो याद रखने में क्या ही नहीं, right? We have so many password, हमारा क्लाउड भी जा रहा है, हमारे सिस्टम लॉग्स भी है, हमारे वाईफाई के भी पासवर्ड है, फिर कंपनी में आके जीरा पे लॉगिन कर रहा है, वो एक अलग हैंडक है, राइट? सो इसलिए होता होगा मे बी ह्यूमन टेंडेंसी और मे बी ह्यूमन नेचर, राइट? So that's all for my talk actually. If you have any question, feel free to ask here. और अगर आप ज़्यादा शाय तो आप आराम से पूछ सकते हो बैठने के बाद। Any questions so far?
Ask everyone is still awake or not.
सब उठे हुए हैं, राइट?
अभी उठेंगे, अभी उठ गए।
अच्छा उठ गए, सब उठ गए। हाँ खत्म हो गया राइट? सब उठे हुए हैं, राइट? हाथ तो उठा सकते हैं, राइट? हाँ यार सब उठे। मुझे लगा था मतलब सिर्फ वॉलंटियर ही उठे रहेंगे, बाकी सब सो रहे रहेंगे, क्योंकि इनको घूमना पड़ता है ना, ये चाह के नहीं सो सकते हैं। ओके, कोई क्वेश्चन है किसी को? नहीं, सब समझ में आ गया।
अभी नेक्स्ट वन